We already discussed a lot about unsymmetric box. Right now we are going to discuss about symmetric 1D box. What is the symmetric and unsymmetric boxes? See, in the earlier case, our box is like this one. The walls are extending up to infinity, and this region x equal to 0 to x equal to L. This is our box. Here you see this is our x-axis, right? In the x-axis, this is the origin, and about the x equal to 0, the box is only on the right hand side. So about the x equal to 0 axis, there is no symmetry for this box. So we are calling this as unsymmetric box. And we got the equations, the Schrodinger equation of the particle inside a unsymmetric box. What is that? That is psi n of x is equal to root 2 by L sin n pi x by L, and energy we obtained as n is equal to n square pi square h square by 2 m L square, right? Now we want to find out the wave function and energies of a symmetric box. What is the symmetric box? So we are taking the origin at this location, that is, this is our x equal to 0, and let us consider the box is of length, total length L, that is, this is x equal to minus L by 2 and this is x equal to L by 2. So the total length is L, right? And these walls are goes up to infinity. So the particle is trapped inside this box, that is a bounded particle, and now we want to find out the wave function of this particle and energy En of these states, different states. Okay, how we can find out? Now you just look into the symmetric and the unsymmetric boxes. What is the difference? If I am translating this unsymmetric box by x equal to x minus L by 2, I will get a symmetric box, right? See, this x equal to L become x minus L by 2, that is x equal to L by 2. So that is, if I am replacing the x by x minus L by 2 in this equation, I will get the corresponding wave function. So what we will get? Psi n of x equal to root 2 by L. Here the length is not changed, so it is root 2 by L sin n pi by L into x. X is changed to x minus L by 2, right? And now I am going to expand this wave function, that is psi n of x is equal to root 2 by L sin n pi x by L minus, here LL will cancels and remaining is n pi by 2. See, this equation is in the form of sin a minus b. I think you know the expansion of sin a minus b, that is sin a cos b minus cos a sin b. So we can use this expression and expand this wave function. So what we get? We get psi n of x equal to root 2 by L into sin a, that is sin n pi x by L into cos b, that is cos n pi by 2 minus cos a, that is cos n pi x by L into sin n pi by 2. So we got the expansion, and here you see these two terms, cos n pi by 2 and sin n pi by 2 largely depend our wave function. That is, let us consider this cos n pi by 2, and this cos n pi by 2 is equal to 0 if this n values are 1, 3, 5, etc. That is odd values, and this sin n pi by 2 becomes 0 if n equal to 2, 4, 6, etc. That is even values. So we get two wave functions, 2 sine of x for different values of n. That is if n value is 1, 3, 5, etc., that is odd value, then what we get? We get psi n of x is equal to root 2 by L cos n pi x by L. And if n value is equal to 2, 4, 6, etc., that is a even value, then we get the wave function sine of x is equal to root 2 by L sine n pi x by L. And here the cos function is an even function and the sine function is a odd function. Therefore, for a wave function psi 1, we get a function of cos and it will be even. And for another wave function, that is psi 2, the function will be a function of sine and it is a odd one. See, then again psi 3 become cos function and it will be even function. So the wave function of a particle inside a symmetric box will be like this one, even, odd, even, odd, even, odd, like this. Okay. Now we want to, the energy, expression for energy for a one-dimensional symmetric box. Here, we already know the energy is proportional to 1 by L square. That is, the length of the box is same here. So the energy expression will be En equal to n square pi square h square by 2 ml square itself. So there is no change in the energy expression, but there is a small change for wave function of the particle inside a symmetric box and an unsymmetric box. Now we can summarize all this idea about symmetric box and unsymmetric 1D box. That is 1D box. It may be symmetric, or unsymmetric, right? And in the earlier lecture, we found the wave function for a unsymmetric box, 1D box. That is psi n is equal to root 2 by L, where L is the length of the box, right? Into sine n pi x by L, where L is the length of the box. And we got the expression for energy, that is En equal to n square pi square h square by 2 ml square. And for symmetric box, we got a function psi n equal to root 2 by L is here is also length into cos n pi x by length. This is for when n value is 1, 3, 5, etc. That is, n value is when odd, we get a wave function like this one. And n value is even, we get another wave function, that is psi n is equal to root 2 by length of the box into sine n pi x by length, where the n values are 2, 4, 6, etc. That is even value. And energy En, expression for energy En is same, that is n square pi square h square by 2 ml square, because the length of the box is not changing. We are just translating the unsymmetric box, so we got the symmetric box. So length of the box is not changing and the energies depend only on the length of the box. So these are the expression for particle in a unsymmetric and a symmetric 1D box. So very important, don't forget, okay? And let us consider some examples. First, I am considering an unsymmetric box. The walls goes to infinity and here x equal to 0 and x is equal to 2L and increase the length of the box. Now I want to find out the expression for wave function inside this box. What will be it? It will be equal to root 2 by it is length. That is, now the length of the box is 2L. That is root 2 by 2L into sine n pi x by length of the box, that is 2L. So you get psi n is equal to root 1 by L sine n pi x by 2L. And now we want to find out the energy expression, that is En is equal to n square pi square h cut square by 2m into length square. Here length is 2L, that is 2L square. So we get this is equal to n square pi square h cut square by 8m L square. This one is an example for unsymmetric box. Now I am going to consider another example for a symmetric box. So this is our symmetric box. And x is equal to, this position is x is equal to minus L and this is equal to x equal to L. That is, the length of the box is increased. Now the length is 2L. So what will be the wave functions? Here we know for the symmetric box there will be two wave functions. One is of function of sine and one is of function of cos. Okay, so first of all let us consider, that is sine of x will be equal to, first one is for odd one, that is n is equal to 1, 3, 5 etc. That is we get root 2 by length. Here what is the length? Length is 2L into cos n pi x by length. Length is 2L for n equal to 1, 3, 5 etc. That is odd values. And another wave function is corresponds to root 2 by, here length of the box is 2L and this is sine n pi x by 2L. Length is 2L. That is for n is equal to 2, 4, 6 etc. That is even values of n. And for energy En we get this is equal to n square pi square h cut square by 2m L square. That is length square. Here the length is 2L square. See again we got En is equal to n square pi square h cut square by 8m L square. See, the wave functions are different for symmetric and unsymmetric box, but the energies are same for symmetric and unsymmetric box. It is dependent only on the length, right? Now we are going to discuss about probability. Probability of what? Here we have a 1D box of certain length L. The walls are extended up to infinity and there is a particle inside this box. Suppose it is in the ground state. Now I am shifting these walls. Okay, so I get another 1D box with a larger length, right? So it will be some multiples of L and this is up to infinity. Okay, now I want to find out the probability of finding this particle in the new box in its ground state. So the probability of finding the particle in this wave function, that is what I want to find out. How we can find out? So you know there are two type of 1D boxes. One is unsymmetric box and other one is symmetric box. So the probability equations are different for unsymmetric box and symmetric box. So first we will discuss about the probability, that is probability of finding the particle in the ground state of the 1D box when its walls are shifted. Okay, then we will discuss about symmetric box and the probability of finding the particle in the ground state of a 1D box whose walls are shifted. That is, here we are going to discuss about probability of finding the particle in the ground state of new box. Let us discuss unsymmetric box first. Unsymmetric 1D box. Particle in unsymmetric 1D box. Okay, so this is our 1D box of length 0 to L, and there is a particle in the ground state. So I am representing the ground state like this, wave function like this, and now we shifted these walls, so we got another box of new length, that is 0 to 2L. In the new box, the ground state wave function look like this one, and the first excited wave function will look like this one, that is, this is the middle position, and the second excited wave function will look like this one. That is, these are forming stationary waves, right, like this one. And here this wave function will form stationary wave like this one, and this one will form stationary wave like this one. Okay, so for this case, this is the ground state, this is first excited state, and this one is second excited state. When we are extending the walls, the particle in the ground state can occupy the ground state in the new box, or it can occupy the first excited state in the new box, or it can occupy the second excited state in the new box. So for each of these cases, there is a probability to find the particle in the ground state or first excited state or in second excited state. So here we are going to find out the probability. And how we can find out this probability? What is the definition or equation for finding this probability? We already discussed an equation for probability. What is that? That is, probability is equal to integral mod psi square dx. So if you want to find out the probability of finding the particle in an interval a and b, then the limit of integral should be a to b. So then you can find out the probability of finding the particle. Here what we took here, this one is nothing but psi star psi. That is, the particle is in the same state. Okay, that is the probability of finding the particle in the ground state. Okay, that is, when we are taking this probability, we take the ground state wave function and its ground state conjugate of its ground state wave function. Okay, that is psi 1 star psi 1. Here the situation is very different. Here the particle, initially it is in the psi 1 and finally it is in some other state. It may be in phi 1 or this is phi 2 and this is phi 3. And this wave function is not similar as this psi 1 also. So this equation for probability is for psi I equal to psi f. Initial state and final state are same. Here initial state and final state are same. Okay, such a case we can use this expression. But for this kind of cases, that initially the particle is in one state and finally it is in some another state, psi 1, psi 2 or psi 3. So definitely you can see the wave function is different because the length of the box is different. Okay, so this is the case. Then what will be the equation for probability? That is, initial wave function is not equal to the final wave function. Then we have an equation. That equation is not for probability, but it is for probability amplitude. Both are different. And this equation is as follows. That is equal to integral psi initial wave function star psi final wave function into dx. And how this probability amplitude and probability are related? Probability is equal to modulus square of probability amplitude. So once you find out the probability amplitude, take the modulus square, you get the probability of finding the particle. And here in the expression for probability amplitude, integral is there. And what is this limit of this integral? Here you see, initially the length of the box is 0 to L only. That is, length is L. Finally, the length of the box is 0 to 2L. So, in which interval we have to integrate? That is a question. That is, which one you have to choose as x1 and which value you have to choose as x2. So here you see, what is the common interval here? 0 to L and 0 to 2L. So 0 to L is common interval in both the case. So when integrating, take the common interval. Okay. Now let us consider an example problem. So initially the particle is in a box of length L. And now the walls are shifted and we got another unsymmetric box of length 0 to 2L, like this one. And initially the particle is in the ground state, and when the walls are shifted, the particle occupied the first excited state. So the corresponding standing wave will be like this one, right? And this is its ground state. So the particle occupied the first excited state. So to solve this problem, what we have to find out? We have to find out probability amplitude. And what is probability amplitude? This is equal to integral psi initial wave function star into psi final wave function into dx. And what is the limit of this integral? That should be the common value, that is 0 to L. Right? If you are taking 0 to 2L, then that is not a common value because this box is only up to 0 to L. Okay, so the common interval is 0 to L. So we have to find out the wave function psi I, and we have to find out the wave function psi final. So what is the wave function of ground state of a particle in 1D box? I think you know the equation, that is root 2 by L sine n pi x by L. That is, L is the length of this box. And what will be the wave function of particle in first excited state in the new box? That will be equal to root 2 by length of the box is, now it is 2L sine n. N is n equal to 1 is the ground state, n equal to 2 is the first excited state. So n value is here 2. Here it is 1. Okay. 2 pi x by length is 2L. So we got initial wave function is equal to root 2 by L sine pi x by L, and psi f equal to root 1 by L into sine pi x by L. And if you are taking the conjugate of this initial wave function, there is no complex terms, that is I terms are not there. So the same wave function we will get, right? Now we can substitute those values in the equation, that is probability amplitude is equal to integral 0 to L psi I star, that is root of 2 by L sine pi x by L into psi final, that is root 1 by L sine pi x by L into dx. See, these are common terms, so we can take it outside the integral, that is probability amplitude is equal to root 2 by L integral 0 to L sin square pi x by L dx. We already discussed the value of sin square theta or sin square x over a full integral or a half integral. So what we get? Use the trick. So we get root 2 by L into 1 by 2 into the limit, that is L. So what we get? This LL will cancels and remaining is 1 by root 2. So this is probability amplitude only. So to get the probability, we have to take modulus square of probability amplitude. So what we get? We get modulus square of 1 by root 2, that is equal to 1 by 2, that is probability is 50%. Okay. This one is another example problem. So initially the particle is in a box of length 0 to L and it is in the ground state. The walls are up to infinity and the particle is in the ground state. Okay. And I am extending the walls and I get a new box, that is a box of new length, that is 0 to L. Now again the particle is in the ground state. That is, I want to find out the probability of finding the particle in ground state of new box. So what is the equation? We have to find out the probability amplitude first, that is equal to integral over the common limit and the psi I star psi f into dx. Here this is the initial state and this is the final state, right? And what is the equation for initial state? We know for a box it will be root 2 by L sin, here n is 1 because it is a ground state. Therefore sin n pi, that is pi x by length of the box is L. And what is the wave function of final state? That is equal to root 2 by length of the box, that is 2L sin n. Here n is 1 because it is in a ground state. So n is 1 pi x by length of the box, that is 2L. That is, these are the wave functions. So first of all we have to find out the probability amplitude. Then we can find out the probability is equal to modulus square of probability amplitude. So first we have to evaluate this one, this integral, that is probability amplitude is equal to integral of psi I star psi f. That is what we get. We can take the constant terms outside the integral. So this 2 and 2 will cancels and remaining we get root 2 by L into sin pi x by L into sin pi x by 2L into dx. Here I am taking this term as m and here I am taking this term, that is pi by 2L as n. So now this equation in the form of integral sin mx sin nx dx. What is the integral formula for this one? This will be equal to sin m minus n x by 2m minus n minus sin m plus n x by 2 into m plus n. This is the value of integral of product of sin mx and sin nx. I think you are remembering this equation, right? So now we can substitute these values of m and n. Here m value is this one and n value is this one. So substitute these values and we have to substitute the limit. Here the common limit is 0 to L. Okay, so we get probability amplitude is equal to, first of all we have to substitute this m and n values, that is root 2 by L into sin m value is pi by L minus n value is pi by 2L into x by 2 into m is pi by L minus pi by 2L minus sin m plus n, that is pi by L plus pi by 2L into x divided by 2 into pi by L plus pi by 2L. And we have to substitute the limits also, that is limit is from 0 to L. So what we get? We get probability amplitude is equal to root 2 by L into, what is the value of pi by L minus pi by 2L? That will be equal to sin pi by 2L, right? Divide by 2 into pi by 2L minus sin 3 pi by 2L x divided by 2 into 3 pi by 2L. And we have to substitute this limit also 0 to L. And here you can see these values will cancels. This 2 and 2 will cancels. And now we can substitute for upper limit. That is, we get probability amplitude is equal to root 2 by L into sin pi by 2L into x. When we are substituting this L value here, this L and this L will cancel and we get sin pi by 2. The value of sin pi by 2 is 1. So 1 by pi by L minus, now we have to substitute L value for this x. So this L and this L will cancel and we get sin 3 pi by 2. The value of sin 3 pi by 2 is minus 1. That is minus into minus 1 by 3 pi by L. And when we are substituting the lower limit 0 value, so we get 0. Okay, so the substitution is over. And what we will get? Now we have to just rearrange this equation. That is, probability amplitude is equal to root 2 by L into L by pi plus L by 3 pi. Now I want to make the denominator common term. So I am multiplying this with 3 and dividing with 3. So finally we get probability amplitude is equal to root 2 by L into 4L by 3 pi. Here we can cancel this L and L. So finally we get probability amplitude value is equal to 4 root 2 by 3 pi. Now what we have to find out? We have to find out the probability, that is equal to modulus square of probability amplitude. So what we get? We get 32 by 9 pi square, right? This problem is not a difficult one, right? But anyway, I tell you a ready-made equation to find the probability amplitude. So you just substitute some values in that equation, you will get the probability amplitude. Then to find out the probability, you have to just take its modulus square. Okay, the trick. So here initially the box is unsymmetric box and I am extending its wall. Again I am getting a unsymmetric box. And initially the particle is in the ground state and finally the particle is in mth state. That is m equal to 1 for ground state, m equal to 2 for first excited state and m equal to 3 for second excited state, etc. So this is the m value and initial length of the box is L, and after shifting we get a new box of length NL, that is the integer multiple of length L. Okay, these are the conditions to use this trick. That is, initially this is the box 0 to L. It's unsymmetric because this is the 0. Okay. And we are shifting its wall, so we get a new box, that is this one. Say infinite potential box also. And the length is now becomes 0 to NL. That is integer multiple of the length. And this particle, initially it is in the ground state. And when the walls of the box are shifted, the particle might appear in the ground state, first excited state, or in second excited state. That is, for ground state, the m value equal to 1, first excited state m value equal to 2, and second excited state m value equal to 3. You should remember these conditions. Okay, then only you can use this trick. So the trick is probability amplitude is equal to 1 by root 2 if the m value is equal to n value, and the probability amplitude will be equal to root n by pi into sine n minus m into pi by n divided by n minus m minus sine n plus m pi by n divided by n plus m. And this is for if m value is not equal to n value. So this is the trick to find out the probability amplitude. So once you got the probability amplitude, you can find out the probability, that is equal to mod the square of probability amplitude. Okay. Now let us check our previous example problem by this trick. So the first example problem is the particle is initially in the ground state of a box of length 0 to L, and later the length of the box is 2L, and the particle is in the first excited state. Here it is in the ground state, right? So for first excited state, the m value is equal to 2, and the n value, that is equal to 2. So here m equal to n. So what we get? We get probability amplitude is equal to 1 by root 2. Therefore, when we taking the probability, we get modulus of probability amplitude square, that is equal to 1 by 2. This is the same value we got earlier by solving the integral and all, right? And now we can check this trick for our second example. That is, initially the particle is in a box of length L, and it is in the ground state, and the walls are extended or shifted. So we got a new box of length 2L, and the particle is in the ground state itself. So we have to find out the probability of finding the particle in the ground state of new box, right? So here, what is the values? M value is, it is in the ground state, therefore m value equal to 1. And what is the n value? Here n value is 2. So now we can find out the probability amplitude by our trick, that is equal to root n by pi, that is n is equal to 2 by pi into sine n minus m, that is n minus m by 2, that is sine of pi by 2 by n minus m, that is 1, minus sine n plus m, that is 3 pi by n, that is 2 by n plus m, that is 3. So we get this is equal to root 2 by pi into sine pi by 2 is 1 minus sine 3 pi by 2 is minus 1, that is plus 1 by 3, that is equal to probability amplitude equal to root 2 by pi into 4 by 3. That is, we got probability amplitude equal to 4 root 2 by 3 pi, and the probability is equal to mod square of probability amplitude, that is equal to 32 by 9 pi square. See, the same result we got just by substituting some m and n values in this equation. So this trick is valid for all. Okay. In the earlier classes, we discussed about normalization and we discussed about time evolution and we discussed about the orthogonality condition and we discussed about expectation value. Okay, so now we discussed all about 1D box, particularly in a 1D box, and there are two cases, that is the box may be unsymmetric box or the box may be a symmetric box. And you know the wave function for unsymmetric box and also for symmetric box, and you know the equation for energies of unsymmetric box and symmetric box. And I told you the energy will be equal for both the unsymmetric and symmetric case. I think you know about the wave functions and the equation for energy for particle in 1D box. Okay, so for a particle in a 1D box, we can do some normalizations, we can do some time evolutions, and we can check the orthogonality of two wave functions after some time, and we can find out the expectation value of various quantities like x, x square, px, px square, etc. So here we are going to discuss about all these quantities specifically to 1D box. That is, we are working with the wave functions of unsymmetric and symmetric box and energies of unsymmetric and symmetric box. Okay. Let us consider one example problem. Here a particle is confined to a box of length a, right? And the wave function is given, and the question is to find out a, where a is the normalization constant. Okay, and wave function at time t, that is we have to find out the normalization and the time evolution. So how we can do this? First you have to normalize this wave function. I already told you, after normalization only wave function, the mathematical expression can really represent the physical condition of the particle. Okay, so here the wave function is given, that is at time t equal to 0, that is I of x is equal to a sine 3 pi x by a into cos pi x by a. Here there is a problem. We are not familiar with a wave function which is multiple of 2. See, this is one sine function and this is a cos function. Here the wave function is a product of sine and cos. When we are discussing the wave function of a particle in 1D box, there will be two cases. That is, one may be unsymmetric. So we got a function of sine, that is root 2 by L, sine n pi x by L, and for symmetric case we got two combination, one is sine combination and one is cos combination, but we didn't see a combination of sine and the cos. Okay, so what we have to do? So we have to separate into independent terms like a function of sine only and function of cos only. Okay, so how we can do this? Here we have to do some mathematical manipulations. That is, see, I am going to rewrite this equation as psi of x0 is equal to a by 2 into 2 sine 3 pi x by a into cos pi x by a. Here I am taking this term as a and this term as b. See, now this expression is nothing but 2 sine a cos b. I think you are familiar with this expansion, that is 2 sine a cos b equal to sine a plus b plus sine a minus b. Now the product term is converted to addition of two terms, that is two independent wave functions. Okay, so by using this equation we can rewrite this psi of x0 is equal to a by 2 into sine a plus b. So here a is 3 pi by a and b is pi by a. So we get sine 4 pi by a x plus sine a minus b, that is 3 pi by a minus pi by a, that is 2 pi by a into x. Right. Again I am rewriting this expression, that is psi of x0 is equal to a by 2 into root of a by 2 into root 2 by a sine 4 pi x by a plus root 2 by a sine 2 pi x by a. Why? Because for a wave function there will be this term, that is root 2 by a. I told you the wave function will be is equal to root 2 by length of the box into sine. For this case this is an unsymmetric box, so it will be a function of sine, that is sine n pi x by length of the box. Okay, so the wave function of nth state will be like this one. So now I can use this expression and I can write the corresponding side term for these terms. That is, I get psi of x0 equal to a by 2 into root a by 2 into, first one is, see this one is n is 4, that is this is equal to psi 4 plus here n is equal to 2, that is this is corresponds to psi 2. Now we got the equation in very simple and easy form. Okay. And the first question is find a. To find the a value, we have to normalize this wave function. What is the condition for normalization? That is integral psi star psi dx. Here the range is 0 to a and we have to equate this value to 1. And in Dirac notation, we express the normalization condition as bra psi get psi equal to 1. Okay. Now we can write this expression, the wave function, in the Dirac notations. That is, ket x0 is equal to a by 2 into root of a by 2 into ket psi 4 plus ket psi 2. Okay, now we can use this equation, that is bra psi ket psi is equal to, that is a by 2 into root of a by 2 into bra psi 4 plus bra psi 2. So first time we have to take the ket psi, that is into a by 2 root a by 2 into ket psi 4 plus ket psi 2. Now we know how to multiply these terms, and we know bra psi 4 ket psi 4 will be equal to 1 and bra psi 2 into ket psi 2 will be equal to 1, and all other term will be equal to 0 because of orthogonality conditions. Because every vector in quantum mechanics is orthonormal. So we get this value is equal to bra psi ket psi is equal to a square by 4, that is multiplying this one and this one, and into root a by 2 in root a by 2, that is a by 2 into this terms, that is here you get 1 value plus 1. And as per normalization condition, this should be equal to 1. So what we get? We will get a square by 4 into a, and this 2 and this 2 will cancels, that is equal to 1. So we get a square is equal to 4 by a, and we get a value is equal to 2 by So this is the value of A. Okay. Now by substituting this A value in the above equation, that is psi of x0 is equal to A, that is 2 by 2 root A into root A by 2 psi 4 plus psi 2. So this is the normalized wave function. See, here we can cancel this 2 and 2 and root 2 and root 2. So finally we will get psi of x0 is equal to 1 by root 2 into psi 4 plus psi 2. So this is the wave function at a time t equal to 0. Now the second question is find the wave function at time t. I already told you how we can find out the time evolution of a wave function. So by using that equation, we will get psi of xt is equal to 1 by root 2 into psi 4 into e raised to minus I e4 t by h cross, where e4 is the energy associated with this wave function, psi 4 plus psi 2 e raised to minus I e2 t by h cross. This is for a particle in a 1D box of length L. So the expression for energy En is equal to n square pi square h cut square by 2m L square. So by substituting this value n equal to 2 and n equal to 4, you will get the corresponding energy values, that is E2 is equal to 4 pi square h cut square by 2 ml square, and you get E4 is equal to 4 square pi square h cut square by 2 ml square. So by substituting these values in this above expression, you will get the wave function at a time t. This one is an example problem, and here this question is related to time evolution. We already discussed about time evolution, and I think you are remembering the equation for time evolution. So here the given wave function, that is psi of x0, is at time equal to 0, and we have to find the corresponding wave function at time t equal to 2 ml square by pi h cross. This is the question. So the equation for time evolution is like this, that is xt is equal to 1 by root 5 into psi 1 e raised to minus I e1 t by h cross plus 2 psi 2 e raised to minus I e2 t by h cross. That is, E1 is the energy associated with the wave function psi 1 and E2 is the energy associated with the wave function psi 2, right? And this question is about a unsymmetric 1D box, and we know the energies of unsymmetric 1D box. We know for both symmetric and unsymmetric 1D box, the energy equation is same, that is En equal to n square pi square h cut square by 2m L square, where L is the length of the box, right? And by substituting n equal to 1, we will get E1, and by substituting n equal to 2, we will get psi 2. So we can substitute the values of E1 and E2 and also the time t in this equation, that is psi of xt is equal to 1 by root 5 into psi 1 e raised to minus I E1 value is equal to, when we are substituting n in this equation, we get it is equal to pi square h cut square by 2m L square into t is equal to 2m L square by pi h cross by h cross, that is 1 by h cross, plus second time, that is 2 into psi 2 e raised to minus I into E2. E2 will be equal to, we have to substitute this to value in this equation, so we get 4 pi square h cut square by 2m L square into the time. Time is equal to 2m L square by pi h cross into here 1 by h cross is there, that is 1 by h cross. So we can cancel this 2ml square and 2ml square, and this h cut square and this h cross will cancels, and 1 pi and this pi will cancels, and here also this 2ml square will cancels, and h cross and h cross square will cancels, and one of the pi and this pi will cancel. So the remaining term is psi of xt equal to 1 by root 5 psi 1 e raised to minus I pi plus 2 psi 2 e raised to minus I for pi. Now we have to evaluate for e raised to minus I pi and e raised to minus I for pi, and substituting those values we will get the wave function at time t. So we know generally the expression e raised to I theta is equal to cos theta plus I sin theta, right? So e raised to minus I pi is equal to cos pi minus I sin pi, where we know sin pi is equal to 0 and cos pi value is equal to minus 1. And the other term, that is e raised to minus I for pi, that is equal to cos for pi minus I sin for pi. We know sin for pi value is equal to 0 and cos for pi is plus 1. So we can substitute these values here. So we get the wave function at time t equal to 1 by root 5 into psi 1, where e raised to minus I pi is equal to minus. So minus psi 1 plus 2 psi 2. So this is the answer. This one is a work for you. Please find the wave function at time equal to 2ml square by pi h cross. It's a work for you. This one is another example problem. Here the question is to find A and also find time evolution of this wave function. Right. So how we solve this problem? Is this wave functions are similar to you? We know the wave function of a particle in the 1D box is look like psi n equal to root 2 by length. Here the length is a sin n pi x by l. Here check whether the given wave functions are in the form of this one. No, right? These are different. There is some terms are missing. So we have to add these terms. So we can write this wave function as psi 1 or psi 2 or etc. Okay. So first we are going to modify this given equation in the form of noun values. That is psi is equal to a into 2 into, we have to add a term, that is root 2 by a. So we have to subtract this term, that is we get root a by 2. Okay, so this effect is nil. Okay, into sin pi x by a plus, again we have to add a term to this sine function, that is root 2 by a sin 3 pi x by a. So now we can rewrite this wave function in the form of psi 1, psi 2, psi 3, etc. That is psi is equal to a root a by 2 into 2 into this term. This term is nothing but, see, n value is 1, right? So we get a into psi 1 plus, here the n value is 3, that is psi 3. So we got the wave function at time t equal to 0. Now we have to find out this a. How we can find out? We have to do the normalization. What is that? That is bra psi get psi. So just by looking into the equation, you can directly write the condition, that is this is equal to 1. So just look into the problem. and just write the normalization condition, that is a square into a by 2 into 2 into 2, that is 4, plus 1 is equal to 1. So by manipulating this equation, you will get a value equal to root 2 by 5a. Now we can substitute this value in this equation for a, so we get the normalized wave function. That is the normalized wave function at time t equal to 0 is equal to root of 2 by 5a into root a by 2 into 2 psi 1 plus psi 3. So here you can cancel this a and the 2 and 2. So you will get psi of x0 is equal to root 1 by 5 into 2 psi 1 plus psi 3. Now the second question is to find out the time evolution of wave function. That is, we have to find out the wave function at time t. That is root 1 by 5 into 2 psi 1 e raised to minus I even t by h cross plus psi 3 e raised to minus I e3t by h cross. And you know the expression for energy, that is En is equal to n square pi square h cut square by 2 ml square. So you have to find out values of E1 and E3 and substitute those values here. You will get the final result. Okay. This one is a work for you. Here the wave function is given. It is at a time t equal to 0, and you have to find this a value, and also you have to find the wave function at the time t. It's a very simple problem, right? So please do it. See, this one is a very interesting question. A particle in a 1D box is oscillating between two states. That is, there are two states. I am calling this as psi 1 and this is psi 2. And the particle is oscillating between these two states. That is, it jumped to psi 2 from psi 1 and again it jumped from psi 2 to psi 1. That is, it is oscillating. So the wave function of such a particle will be combination of psi 1 and psi 2. That is, the particle can be in psi 1 state or in psi 2 state. That is, the state of the particle is combination of these two states. That is, psi is equal to 1 by root 2 psi 1 plus psi 2. Now the question is, what is the time taken by it to go from one state to other? Here each of these state have certain energy. That is, for psi 1 it will be E1 and psi 2 it will be E2. Therefore the energy difference between these two states is E2 minus E1. And we can relate this is equal to h nu, or we can write this is equal to h cross omega. Therefore we get the omega, that is angular frequency, is equal to E2 minus E1 by h cross. And here the question is time taken by it to go from one state to other. So from this omega we can find out the time period. Time period is the time taken for this oscillation. That is, so that time period is t is equal to 2 pi by omega. That is equal to 2 pi by omega is E2 minus E1 into h cross, where we know h cross equal to h by 2 pi, right? That is, this is equal to h by E2 minus E1. So this is the time period, and here the question is to find the time for the particle to go from state psi 1 to psi 2. So half of the time period is this value. That is, we get this is equal to h by 2 into E2 minus E1. We now, for a 1D symmetric box, that is, the length of the box is 0 to L. We know the wave function, that is psi of x nx equal to root 2 by L sine n pi x by L. And we know the energy of the particle in this box, that is n square pi square h square by 2m L square. Now we have to find out the probability density. That is nothing but distribution function. That is this wave function. Definitely this wave function is time independent wave function. So we are going to find out the probability density at the time t equal to 0. So what we will get? This is equal to psi star x0 into psi of x0, that is equal to mod of psi of x0 all square. So now we can find out this value, that is we get rho of x0 is equal to 2 by L sine square n pi x by L. This is a general equation for any wave function, that is rho n. Okay, so this is for wave function at the time t equal to 0. Now I am going to consider another case. Now the wave function psi n of xt, wave function at time t. That is, we know from the time evolution equations we can find out it will be equal to root 2 by L sine n pi x by L into e raised to minus I en t by h cross. So again we can find out the probability density. That is rho of xt. So here what we will get as rho of xt. This is for rho n, right? That is equal to psi star xt into psi of xt, right? That is rho n of xt is equal to psi star of xt. Here there is a item, so we have to take its conjugate. So we get root 2 by L sine n pi x by L into conjugate of this term will be equal to e raised to plus I en t by h cross into this term psi of xt, that is root 2 by L sine n pi x by L into e raised to minus I en t by h cross. When we are multiplying these two terms, we get this is equal to 1. So the rho n of xt is equal to 2 by L sine square n pi x by L. So from the cases A and B, we can conclude that if the wave function is sine of x equal to root 2 by L sine n pi x by L. See, there is no time term in this wave function. That is, this is a stationary state. And you see, in the earlier case also, that is in the case A also, we got rho n of x0 are same. That is, if this is a stationary state, then rho n of x0 will be equal to rho n of xt. That is, probability density does not change with respect to time. Okay, so this is the conclusion we got from these two examples A and B. Here the wave function is not changing with the time, therefore probability density is also not changing with the time. linear combinations of states. See, till now we discussed about a single state, that is, a particle will be in a 1D box and the particle is in a ground state. Okay, so we can find out this wave function, that is psi 1 is equal to root 2 by L sine pi x by L, if the length of the box is 0 to L. Now, the particle is in a combination of states, that is, particle will be there in the ground state and maybe it is in the first exciter state. That is, particle is oscillating between these two states. That is, particle can exist in state psi 1 and also it can exist in state psi 2. So, the wave function will be a combination, that is, psi will be equal to A psi 1 plus B psi 2. Here this particle can have a certain probability of mod A square to be found in state psi 1 and a probability of mod psi square to be found in state psi 2. Okay, it is little complicated case. Now we are going to deal with such linear combination of states. Let us consider a state psi which is a linear combination of two different states, that is A psi 1 plus B psi 2, where this wave function is at a time t equal to 0. Now I want to find out this conjugate, that is psi star x0, that will be equal to A star psi 1 star plus B star psi 2 star. Now we want to find out the density, that is rho x0, that will be equal to, we know the definition, that is psi star x0 into psi of x0, right? Now we can substitute these values here, that is rho of x0 is equal to psi star x0, that is A star psi 1 star plus B star psi 2 star into psi of x0, that is A psi 1 plus B psi 2. So we can multiply, that is we get A star A psi 1 star psi 1 plus B star B psi 2 star psi 2 plus A star B psi 1 star psi 2 plus B star A psi 2 star psi 1. So this is our rho of x0. Here, what is this A star A? That is nothing but modulus square of A into modulus square of psi 1 square plus B star B is modulus square of B square into modulus square of psi 2 plus A star B psi 1 star psi 2 plus B star A psi 2 star psi 1. And if this A and B are real values, real constants, and psi 1 and psi 2 are also real, that means its conjugate will be that itself. That is, if we take conjugate of A star, we get A. Similarly, for wave function, if we take the conjugate of psi 1 star, we will get psi 1. That is, these are real values. There is no complex items in the equations of A and the psi. Okay, so this equation will reduce us to the following form, that is rho of x0 is equal to A square psi 1 square plus B square psi 2 square plus 2AB psi 1 psi 2. Now we are going to make the earlier case little more complicated. So I am calling this case as B and you just name the earlier case as A. So we are considering a wave function psi which is a linear combination of psi 1 and psi 2. And this wave function is at a time t equal to 0. Now I want to find out the wave function at time t. That is, we can use the time evolution equation. So we get a psi 1 e raised to minus I e1 t by h cross plus b psi 2 e raised to minus I e2 t by h cross. Now I want to find out its conjugate, that is psi star of xt, that is equal to a star psi 1 star e raised to conjugate of minus I, that will be plus, right? That is I e1 t by h cross plus b star psi 2 star e raised to plus I e2 t by h cross. Now again I am going to find out the probability density, that is rho of xt. That is, now we are going to evaluate this at a time t, that is equal to psi star xt into psi of xt. That is, we can substitute these values. A psi 1 e raised to minus I e1 t by h cross plus b psi 2 e raised to minus I e2 t by h cross into second time, that is a star psi 1 star e raised to I e1 t by h cross plus b star psi 2 star e raised to I e2 t by h cross. Now multiply. So you will get rho of xt, that will be equal to a star psi 1 star into product of e raised to this term and this term will be equal to 1, right? Plus second time I am considering, that is b star psi 2 star. Again the product of this term and this term will be equal to plus. Now we can take the other terms, that is a psi 1 into b star psi 2 star into e raised to minus I e1 t by h cross into e raised to I e2 t by h cross plus b into psi 2 a star psi 1 star into e raised to minus I e2 t by h cross into e raised to I e1 t by h cross. That is rho of xt is equal to a star, that is mod a square, and the psi 1 psi star, that is mod psi 1 square plus mod b square into mod psi 2 square plus a into b star psi 1 psi 2 star into, we can take the product of exponential term, that is into e raised to minus I into e1 minus e2 into t by h cross plus the last term is b a star psi 2 psi 1 star into e raised to I e1 minus e2 t by h cross. And if this a and b are real, and also this psi 1 and psi 2 are also real, then we can rewrite this equation as follows. That is rho of xt is equal to a square psi 1 square plus b square psi 2 square plus ab psi 1 psi 2 into, because this is a common term and we can take the exponential term inside the bracket, that is e raised to I e1 minus e2 into t by h cross plus e raised to minus I e1 minus e2 t by h cross. Here I am dividing this term by 2 and multiplying this by 2. So we know exponential function like e raised to I theta plus e raised to minus I theta by 2 is equal to cos theta. Right. So we can use this equation and we can rewrite this expression for probability density, that is rho of xt is equal to a square psi 1 square plus b square psi 2 square plus 2ab psi 1 psi 2 into cos of theta is e1 minus e2 t by h cross. So this is the expression for probability density at time t. Expectation value of linear combination of states. We are all familiar with the expectation value of x and x square in 1D box. That is, we already discussed there are two types of 1D box. One is unsymmetric 1D box and other is symmetric 1D box. For unsymmetric 1D box, it will be from some 0 to L, and the symmetric 1D box is from minus L by 2 to L by 2. So this symmetric 1D box is symmetric about x equal to 0. And we call this as unsymmetric because it is unsymmetric about x equal to 0. And we know the wave function, that is psi n is equal to root 2 by L sin n pi x by L. And for a symmetric box, there will be two type of wave functions, that is psi n will be equal to root 2 by L cos n pi x by L for n values equal to 1, 3, 5, etc. And the wave function will be psi n equal to root 2 by L sin n pi x by L for n values equal to 2, 4, 6, etc. And we know the energies, that is En is equal to n square pi square h square by 2 ml square, and here the energy is same as unsymmetric box, that is n square pi square h square by 2 ml square. And the expectation value x for unsymmetric box is equal to L by 2, because this is our box of length L. So this is x-axis or x coordinate, x value. So average of this x value, that is 0 plus L by 2, that is L by 2. So we already discussed the expectation value is nothing but average value. So average value of 0 to L is L by 2, right? And for symmetric box, this expectation value is equal to 0. Why? Because for a symmetric box, this side is minus L by 2 and this is plus L by 2. So average, that is adding this 2 by 2, that is minus L by 2 plus L by 2 by 2 is equal to 0. That is average value of x is 0 here. Fourth one, the expectation value of x square for unsymmetric box. That is also we already discussed, that is equal to L square by 3 minus L square by 2 n square pi square. And expectation value for unsymmetric box, that is x square is equal to L square by 12 minus L square by 2 n square pi square. Here what is this expectation value of x square? That is bra psi n x square get psi n. See, these wave functions are same. Okay, here also. So we are finding the expectation value about only a one wave function. Now we are going to consider a linear combination of states, that is psi is equal to a psi 1 plus b psi 2. So when we are going to take expectation value of x, That means equal to bra psi x get psi. So we have to substitute for this psi value. Okay, so we will get a combination of these two also. That is, if you substitute these values, we get expectation value of x is equal to bra a psi 1 plus bra b psi 2 into x into get a psi 1 plus get b psi 2. Now this problem is little more complicated. So that is what we are going to solve. Okay, that is, our wave function is a linear combination of two states, that is psi is equal to a psi 1 plus b psi 2. And the question is to find expectation value of x. Here x is an operator, so we use a hat to represent it. That is, the hat means that is an operator, that is x operator. So we have to find out expectation value of x. That is equal to, we know the basic equation, integral equation is integral psi star x psi dx. So here this x cap, that is an operator, it has nothing to do on psi. That is, I tell you one example, that is, we know the momentum operator p, that is minus I h cross dou by dou x. So if p is acting on some wave function psi, what happens? It will take the derivative of this wave function. But here the x cap operator is nothing but x itself. Therefore this x has nothing to do on our wave function. So we can rewrite this as integral x psi star psi dx. That is, expectation value of x is equal to integral x. Here this is nothing but probability density, that is rho of x0 into dx. Here this wave function is at x and time t equal to 0. That is why we got rho of x0. Okay. Here this wave function psi 1, psi 2 are wave functions of a 1D box of length 0 to L, and it is a unsymmetric box. So that is the case we are going to deal. So here this integral value is from 0 to L, right? Here you see we already solved for rho of x0. What is the value of rho of x0? That is a square psi 1 square plus b square psi 2 square plus 2ab psi 1 psi 2. So we can substitute this value in this integral, that is expectation value of x is equal to integral 0 to L x into a square psi 1 square plus b square psi 2 square plus 2ab psi 1 psi 2 into dx. So we can separate this integral, that is equal to integral 0 to L. Here we can take this a square outside into x psi 1 square dx plus integral b square into 0 to L x psi 2 square dx plus 2ab integral 0 to L x into psi 1 psi 2 into dx. Now we have to evaluate each of these terms. Here this first term, this term is nothing but expectation value of psi 1 x psi 1. This is the Dirac notation, and above is integral form. Okay, that is what we call expectation value of x with respect to the wave function 1 plus, here again we get expectation value of x with respect to wave function 2 plus 2ab integral 0 to L x into psi 1 psi 2 dx. Here I missed two terms, that is a square and b square. Okay, and just before I told you the expectation value of x for a unsymmetric box, that is length 0 to L. So the expectation value will be the average value of x, that is this one, L by 2. Okay, so we get this is equal to a square into L by 2 plus b square into L by 2 plus 2ab into integral 0 to L x psi 1 psi 2 dx. Now we have to evaluate this integral. So to evaluate this integral, we have to know the value of psi 2. What is psi 2? We know that is equal to root 2 by L sine n. Here n will be 2. That is 2 pi x by L. And what is the value of psi 1? Psi 1 will be equal to root 2 by L sine n value is equal to 1 pi x by L. So if we got the value of this last integral, we can find out the expectation value of x for this linear combination of states, right? So we have to do this integration, that is integral 0 to L x into psi 1, that is I can take this common terms, that is 2 by L I am taking outside, into sine 2 pi x by L into sine pi x by L dx. Here this is a product of two sine terms, and if I am calling this as A and this term as B, then I can rewrite this equation by using trigonometric relations. That is, we know 2 sine A sine B is equal to cos A minus B minus cos A plus B. So here I am taking this 2 term inside this integral. So I can rewrite this equation as 1 by L integral 0 to L x into cos A value is 2 pi by L minus B, that is pi by L into x minus cos into A plus B, that is 3 pi by L into x into dx. So we can separate these integrals, that is 1 by L integral 0 to L x into cos pi x by L dx minus 1 by L integral 0 to L x cos 3 pi x by L into dx. Here I already told you a trick to solve this kind of integrals. Are you remembering? What is the trick? See, here x is there, I am writing x here. And another term is cos pi x by L. Now I am going to take derivative of this x term. So first I get 1, and again I am taking the derivative of 1, so I will get 0. So there is no more derivatives. And here I am going to take integral of this function. So integral of cos pi x by L will give sin pi x by L into L by pi. Now we have to take the integral of this function. So what is the integral of sin? That will be minus cos, that is we got minus L by pi all square cos pi x by L. Now we have to multiply this term. So when we are multiplying, we have to take this as positive, and when we are multiplying, we have to multiply this term with a additional minus value. So what we will get? We get L by pi into x sin pi x by L minus into minus, that is plus L by pi all square into cos pi x by L. So the integration is over. Now we have to substitute the limit, that is limit is 0 to L. So first we are going to substitute this upper limit in the first term, that is L by pi into upper limit is L, that is sin pi L by L. So we get sin pi minus, when we are substituting the 0 value for x, that will be 0, plus L by pi all square into, we have to substitute L for this cos pi x by L, so we'll get cos pi minus cos 0. So here you know sin pi is equal to 0, so this entire term is gone, and the remaining is cos pi is equal to minus 1. Okay, minus cos 0 is 1, so we will get this value equal to L by pi all square into minus 1 minus 1. That is minus 2 into L by pi all square. And this is the value of this integral. And we have to substitute this 1 by L value, that is 1 by L into minus 2 into L by pi all square. So for the first term, we got this is equal to minus 2 L by pi square. Okay, similarly, you can solve for this one. Just use the trick and substitute the limits. So finally, you will get a value. So this is a work for you. Please solve it. I will tell you the final result. The final result of this integral will be equal to 2L by 9 pi square. Okay, so we got the value of this integral, that is equal to minus 2L by pi square plus 2L by 9 pi square. Now we can substitute all these values in the expression for expectation value x. So we will get a square plus b square into L by 2 plus 2ab into the integral value, that is minus 2L by pi square plus 2L by 9 pi square. So we can add these two terms. So finally we will get expectation value x is equal to a square plus b square into L by 2 plus 2ab into minus 16 L by 9 pi square. Here the given wave function, that is psi is equal to a psi 1 plus b psi 2, it is not a normalized wave function. So when we are normalizing this wave function, we will get a normalized wave function psi is equal to 1 by root of a square plus b square into a psi 1 plus b psi 2. So when we are finding this row, we will get a term, that is 1 by a square plus b square. So in this expectation value, we have to multiply this entire term by a square plus b square. That is for the normalized wave function, this expectation value x is equal to L by 2 minus 32 ab by a square plus b square into L by 9 pi square. So this will be the final answer. Here, to solve this problem, we spend a much time to solve the integral. So, is there any way to simply solve this integral? Yes, there is a trick. What is the trick? This trick is applicable in the case of a unsymmetric box. And its length is from 0 to L. Then we can use this trick to find the integral value. That is, we have to integrate 0 to L x psi 1 psi 2 dx. So the trick is, here this value is 1 and here this value is 2. So we have to write this 1 and 2 here. And we have to add 1 and 2, so we get 3. And we have to subtract 2 from 1, so we get minus 1. Then you have to write this 2L by square of 3, that is 9 pi square, minus 2L by square of minus 1, that is 1 pi square. One more example I tell you. If you have to integrate from 0 to L x psi 2 psi 3 dx. So these wave functions are 2 and 3. So write 2 and 3. And now we have to add 2 and 3, that is equal to 5. And you have to subtract 3 from 2, that is minus 1. Now 2L by square of 5, that is 25 pi square, minus 2L by square of minus 1 is 1, that is pi square. So this will be the final answer. See, in the earlier problem we got this answer, right? So we can express it in a much general form. That is, we have to integrate 0 to L x psi n into psi n plus 1 dx. Here you can see the psi n and the psi n plus 1 are successive wave functions. That is, if first one is psi 1, the next one will be psi 2. Then, see, first term is n, next is n plus 1. Now we have to add n and n plus 1, that is 2n plus 1, and subtract this term from n, that is minus 1. Now 2l by this term, that is 2n plus 1 all square pi square minus 2l by this term is minus 1 square, that is pi square only. And this is the first case. And if it is not successive, that is, for this is the case for successive wave functions, and another is non-successive. What will be the integral value? That is integral 0 to L x psi 1 psi 3 into dx. See, psi 1 and psi 3 are not successive. Then this value will be equal to 0. So if you know these conditions, then easily you can find the integral values. But it is not necessary to remember all these equations. I will tell you the final two equations that is sufficient to solve any problem. Here I am going to summarize the ideas of expectation value of linear combination of states. So let us consider a general state, that is a linear combination of two states, that is A psi n plus B psi n plus 1. Then the expectation value at t equal to 0 will be equal to L by 2 plus 2ab by a square plus b square into 2L by 2n plus 1 all square pi square minus 2L by pi square. And if we are considering the time evolution and we are finding the expectation value after some time t, that is expectation value of x at time t will be equal to L by 2 plus 2ab by a square plus b square into 2L by 2n plus 1 all square pi square minus 2L by pi square into cos En minus En plus 1 t by h cross. So please remember these two equations, then you can easily solve the expectation value at time t equal to 0 and at time t. And here I tell you one more thing. If this wave function is normalized, then a square plus b square will be equal to 1. So this equation will reduces to simpler form. But for any wave function, even if it is not normalized, then also you can use this equation to find the solution. Because if it is already normalized, automatically this a square plus b square become equal to 1.